The creative world, as we know it, is right now experiencing one of the biggest disruptions ever seen. And that is because the way we create and design things are undergoing dramatic changes, primarily due to the use of artificial intelligence. And it's happening everywhere, from coding, writing, illustrations, and designs. And let me just give you a few examples. Here we have an algorithm called Jukebox that not only can it write songs, depending on some input from you, what kind of music do I like, but it can also write the lyrics, depending on what you tell them that the song should be about. So let me show you a quick example. What you're going to hear now is actually created by an AI algorithm. So we're hearing a piece of country music. The guy singing is actually an actual singer, but they have taken his voice and turned it into him singing a new lyric that was also created by the AI algorithm. Another example is an algorithm called OpenAI. It's open for all of you to play with right now, and it's a multi-purpose algorithm. I actually used it to get some help on figuring out which questions should I ask regarding sustainability and 3D design. So this is what I put in, and here you can see the questions that the algorithm actually suggests, like what are some of the challenges associated with making 3D printing more sustainable, or how do we ensure that 3D printed products are safe and durable? All these questions generated by an AI algorithm. Maybe some of you are also familiar with these new algorithms, and there's a lot of them. Midjourney is just one of them, where you can actually input some text and then it'll generate a picture for you. Like, for example, I wrote a medieval painting of the Wi-Fi not working, and this is what I got out of it. I also tried this one, an ancient Egyptian painting depicting an argument over whose turn it is to take out the trash. And then I got this one. So take care, because when you start with this, it's really addictive. It's really, really a lot of fun, and you can get amazing results. Now, in our world, we're experiencing the same. And that's because we have a new way of working, which is called computational design or generative design. And the idea here is that it's a design process where you actually don't design the elements, you input, together with the engineers, different forms of design goals, parameters, and output restraints, like, for example, weight, strength, material, spatial requirements, and manufacturing method. And all these parameters goes into the AI algorithm, which then generates a lot of different possible solution and product designs that'll improve each time it iterates. So this is just one example, and the interesting thing about this is that the result is quite surprising. It looks like something generated from nature, very often similar to bone structures. And these designs would almost be impossible to produce if it weren't for additive manufacturing. So that's why this is a great combination. So why go this way? Well, as Melissa also said, there's a lot of advantages here. We can create parts that uses way less material, that also has way less material waste in production. We can construct with fewer parts, so there's the assembly part and the transportation part and everything else. And there's, of course, the ability to reach improvements on other parameters like strength and torsion or whatever it is. And all this kind of leads to more sustainable solution. Let me give you an example from General Motors. This is an example of a seat belt bucket, as you can see here. It's a pretty complicated product because it consists of a lot of different parts, and it's quite important because that's the one taking care of the safety. And here it is actually substituted by one piece instead of the other ones, and it's developed by generative design. So you can see it looks very different. So what was achieved here? Well, first of all, we went from 8 parts to 1 piece. We were able to use 40% less material, and we actually ended up with a part that is 20% stronger than the other construction. So in a time where prices on material are racing like crazy, it makes a lot of sense to reduce the amount of material. I think so, at least. So if you look at the wall on the other side here, it's another example of something constructed with computational design. And the thing here is that to get there, you have to go through a lot of examples, and the job of the designer is actually to pick the one with the right parameters. So as you can see here, there's a line of different products before you actually achieve to the right one. Let me show you another example from the motorcycle industry. They decided that the whole part that takes care of the rear wheel, they would want it to reach a new construction. Here, there's the different parameters like strength and stiffness and mass and cost, and that's fed into the algorithm that then starts producing a lot of different examples of things that would actually work, ending up with more than thousands different examples. But then when you drag the different filters, you can actually zoom that into just a few, and then it's again a job of the designer to test it out, to figure out which of these different examples that are all going to work is the one we're going to go for, either because of aesthetics or where it's easy to produce and so on and so forth, and thereby ending up with the final part. And this is actually in production from this company that are producing these motorcycles. Here's another example that is actually out there. It's Volkswagen that has worked with this newest version of their bus to see how much weight loss could they gain by introducing generative design in producing some of their parts. And they used it in a lot of different areas, but just when we look, just when we look at the wheels, they actually reached a 19% saving in weight as opposed to the old model. And of course, that translates into less fuel usage as well. So it kind of makes a lot of sense. We also see it within architecture. This is an example from Baku, and this is a really interesting structure. Underneath, there's a lot of math and engineering going on to figure out how do we create this mesh grid, and that was actually also done by using additive manufacturing. And if you looked at Melissa's slides, some of the parts that she showed actually was also done by generative design. So kind of like the takeaway here is that the continued need for optimization combined with an increased focus on sustainability is going to drive generative design going forward.